Hello everyone, I am Maheshwari, Assistant Professor, Department of BSc Information Technology at Dr. S.N.S. Rajalakshmi College of Arts and Science. Now I am going to explain about operating system deadlock. It is a very important concept inside the operating system. So we will see about the deadlock in our video. Deadlock and its prevention technique. Before starting in deadlock prevention, we have to know about what is deadlock. So deadlock is a problem. Why it occur means two or more process trying to access same device at the same time. This is called as a deadlock. To avoid deadlock, we can have a different say deadlock prevention, deadlock reduction, and deadlock avoidance techniques, as well as deadlock ignorance techniques. Among this, we first talk about what is deadlock prevention. A deadlock is a situation in an operating system where two or more processes are unable to proceed because each process is waiting for a resource that is being held by another process. This situation creates a standstill where no progress can be until deadlock is resolved. So no process can be processed during the situation of deadlock. To avoid that, we can use a simplest technique called deadlock prevention. A deadlock is a condition that may happen in a system composed of multiple processes that can access shared resources. Once it happens inside between the shared resources, the resources are nothing but printer, monitor, keyboard, or some hardware devices. Types of deadlocks. Here we have a different types of deadlocks. The first one is mutual exclusion, also known as mutex value. The deadlock reduction is another type of deadlock that can occur in an operating system. This is a technique that helps to avoid the deadlock, and if it is also helps to find out the deadlock where it is occurs. Resource allocation graph, or RAGs is a deadlocks which are caused by circular waiting on a set of resources requests between two or more process or threads. RAG is a graph technique which demonstrates how the deadlock is occurred and how we can resolve the deadlock. For example, we have two process, that is P1 and P2. Also we have two resources, that means R1 and R2. If P1 is using R1, but it requests for the resource R2, but R2 is occupied by P2. Also P2 already use R1, that P2 also waiting for R1. So this is called a circular wait. Here P1 is waiting for R2 as well as P2 is waiting for R1. But R1 and R2 are held by P1 and P2. This is situation we call it as a deadlock. In deadlock reduction, fairly a straightforward technique, but the deadlock recovery requires either aborting the process or preempting the resource. If deadlocks are neither prevented nor reduced, then we have deadlock occurs. The systems will gradually slow down. One technique used for preventing deadlock in computer system is the resource allocation graph, that is RAG. In this technique, the resources are represented as nodes and in a directed graph, and the edges represents the requests for resources. The banker's algorithm checks for S states before actually allocating the resource to the process. Resources inside the deadlock, also called AND model. This occurs when the process try to get exclusive access to the resources like files, logs, devices, servers, or other resources. In this model, a process waits until it has received all the resources it has requested. In conclusion, a deadlock is a state in a computing system where two or more processes are unable to proceed because of each is waiting for the other to release a resource. This can cause the system to become unresponsive until one of the processes is killed. Deadlocks can have severe consequences, leading to the system crashes, frozen applications, or unresponsive user interface. They can also lead to reduced throughput, increased response time, and wasted resources. Some consequences of deadlock included freezing up your computer, difficulty restarting your computer, losing important work or data, damaging your to your computer. This is the drawbacks once the deadlock happens. So to avoid that deadlock, we have to use the simplest prevention technique, that is called a deadlock reduction. Thank you.